Good morning. My name is Phyllis Newbill, and I direct the Virginia Tech Science Festival. I'm really glad to see everybody this morning. Thanks for being here. This morning we're here with Miss Birdsall's fourth grade from Westmoreland County. Thanks. It's good to be over on the Northern Neck today. I'm glad to see you all. Joining us, Joanna, I'll let you introduce your team again. Joanna and team, I'll turn it over to you.
Hi everyone, I'm Joanna, and we are all with the Biochemistry Department at Virginia Tech. So I'll let everyone introduce themselves.
Hi everyone, my name's Caitlin.
Hey guys, I'm Maria. I'm Ash. I'm Hannah.
So we're going to talk to you today about strawberry DNA. Does anyone know what strawberry DNA is, or DNA in general? All right, so DNA is the material in your cells that basically makes you who you are. It makes us different from a strawberry or a banana. It tells our cells basically what to do and what to be. So this is super important in science. Scientists study DNA a lot to see what makes different organisms different from each other, and also where we come from, how we've evolved, etc. So extracting DNA is super important, and we're going to show you how to do that today with a strawberry.
So as Joanna said, DNA is super important for all living organisms. It makes, it makes you, and it makes this strawberry or this punnet of strawberries, strawberries. We're going to be extracting the DNA with just everyday items that you can find around the house. So you can do this at home. You can either follow along with us now, or you can do it at another time, of course, with your parent or guardian's permission. Okay, so we're going to start by making the extraction buffer. And so we need to make this buffer, so it's basically a solution of liquids. Once we've added the water into the beaker, we're going to add some dish soap. So you can use any dish soap you have at home.
You only want to do a little bit because you don't want to do too much, because then it's not going to be able to take the DNA out, right?
Yeah. Okay, and so we're going to just mix that up a little bit. Okay, so there we go. We've got our buffer. All right.
Going to mix it up so that everything's all together.
So now we're going to get a plastic sandwich bag, and we're going to get to the fun, messy part. We're going to mush and mash up the strawberry, okay? So we'll get a strawberry. Let's pick the biggest one. We're going to put it in the bag and start mashing it up. Now we want to break it all apart, kind of mush it up so it's all broken up. All right, so once we've mashed that up a little bit, we're going to add some of our extraction buffer. We just want to add a little bit. And then we're going to close the bag. We're going to mush it up some more. Do you want to mash it up? And this is the really fun part. Okay, so once we've got that all mushed up and it's all broken up, we're going to get a funnel. Now you can use either a funnel that you've got at home, or you can use like a coffee basket, and we're going to put a coffee filter inside our funnel.
And that's just going to get rid of all the solid pieces, so that all we have left is liquid, because that's where the DNA is.
Yeah, so then we put our funnel over a beaker, we pour the strawberry mixture in. So as we said, all the solids and kind of strawberry gunk is up here caught in the filter, and our DNA is in this solution down the bottom. So we're going to try and get all that liquid out, because that's where our DNA is, and that's what we want to see. Okay, so we've got all the liquid down here. Can you all see it? This is where our DNA is. But we can't see our DNA right now, and we want to be able to see that and just have the DNA, have nothing else from the strawberry.
All to take a test tube. That's going to make it easier for us to see because this is much clearer than this and smaller. So this is all of the liquid that we took from the strawberry, and all the DNA is in here now, but we need to add something to take the DNA out. So as you can see, you see the liquid starting to separate, and you have this clear section up here, and then you have all of that strawberry juice down here. And right now you can see all these bubbles forming, and that's just pulling the DNA out of the strawberry liquid.
So you see all those bubbles, they're all pulling the strawberry DNA out of the strawberry juice into that alcohol and up to the top. So can you see it rising very slowly? Once that DNA is starting to come to the top, what you can do is get either a coffee stirrer or some kind of stick, and you can pull that DNA out and twist it around.
So she pulled this out of the liquid, and this little thing right here, that's your DNA that we pulled out from the strawberry. Since we were able to pull it out of the liquid, and now we could just take it around the stick.
That's all the information that tells that strawberry to be a strawberry. So we've got it there.
When you eat a strawberry, do you like consume that like the atoms, or do they just stay inside of the strawberry?
So you actually, when you eat a strawberry, the strawberry goes into your stomach, and the acids in your stomach tear it all apart. And so yes, you get to actually take all the parts of the strawberry and make them into parts of you.
Why does it look like slime?
It looks like that because of the way that we extracted it from the strawberry juice, and because DNA is only soluble in some liquids. And so when we pulled it out of the alcohol, that's honestly just how DNA looks when it's in that kind of solution.
Why does it turn white once it goes inside of the bottle, and do you have to use alcohol?
The bubbles forming around it in the alcohol are most likely what's making it appear white at first. Otherwise, I think that's just the color that DNA is, unless anyone has a better explanation.
How many of the fruits, like, do you do vegetables, and how many fruits have you like experimented on like extracted DNA?
We've done it on strawberries, bananas, kiwi fruit, blueberries, raspberries, pineapple, and you can do it on cantaloupe, and you can do this with frozen fruit, fresh fruit. You can do it with vegetables.
Thank you so much to Ms. Birdsall and to all of Ms. Birdsall's students. You all were so wonderful with your questions. And I also want to thank Joanna and the team for their DNA extractions today.